So we do have, oh, you can't see this yet. So what I want to do now is I want to just, rather than doing math on these, what we just discussed is that binomials always reduce to chickens. They reduce to, okay, number one, did you have a fixed number of trials?
Yeah.
Number two, are there two independent outcomes on those fixed number of trials? So what I'm going to do now is I have a number of scenarios that either do or don't describe binomials, and I want you to identify them, because honestly, the math of the binomial, programming notwithstanding, the math does not interest me. What interests me is you being able to go into your careers and your fields and know, that's a binomial. That means I can do this and that and this and that to it. That's what interests me more than anything. So let's look at some old stuff that we've already done in class and identify if it was binomial or not. And then look at some new stuff that we haven't talked about yet and see if it's binomial or not. So here's one of the first experiments we did about 3 weeks ago. Actually, it's not one of the first. It's one of the experiments we did, where I gave you a die and I said roll it a bunch of times, right? But let's say you just roll it one time. Roll it. And count the pips that you get. Is that binomial? Think about it for a couple seconds. I hear a vote for no. Somebody said no.
No.
Vote for no. Jen says no. Lloyd seconds no. We say, tell me your name again. Kara. I'm sorry. No. Tell me why. Kara, no. I agree with you. There's 6 outcomes, right? If you roll a die and you're just counting the number of pips, it's hexanomial. I mean, sure, you did one trial, so it's fixed at one trial, yes? It's fixed at one trial. And yes, any potential outcome is independent of any other potential outcome, but the problem is there's too many outcomes. There are 6 outcomes, not 2. Dave?
But even with like the chick experiment or what have you, if you just spot one, would that still be a binomial experiment because there's 2 outcomes?
Let's change the experiment a smidge. Thank you for the segue, sir. Suppose you do the exact same experiment. You roll a die one time, but now you bet on 3.
Yes.
That becomes binomial, doesn't it? Because now there are 2 outcomes, whether you
Get 3 or
get it or don't, win or lose, you see? So in other words, collapse the other 5 outcomes into one outcome of lose. Sure, it's still theoretically, you can view it as hexanomial, but it seems kind of silly because the outcome you're interested in is whether you won or lost. There's only 2 outcomes, winning or losing. Now you're 5 times more likely to lose if you bet on 3, but there's still only 2 outcomes. So it becomes a coin, right? Win, lose. You need a 6-sided coin up here, conveniently called die, but that's the difference between this and that. Does everybody see the difference there? You can view both of them as hexanomial, but you can also view this one as binomial. That's what makes it powerful. If you can simplify it down to a binomial, you get tools that you don't have otherwise. Fair? Ish, maybe. Potentially. Good. Okay, good. All right. Let's do another one. I think. Yeah, here we go. I need to do this one. Well, we kind of did this one in class. We didn't actually roll 2 dice in class. We had 2 dice and we were analyzing the outcomes of the 2 dice, so it kind of... So one time, throw the dice. Sum the pips. Love that word. Pips. Great donut shop in Portland too, by the way. Pips Donuts. Fantastic donut shop. FYI.
Yes.
Yes. Yes.
Yes.
Oh yeah, I thought you'd been to Pips. No. Anybody been to Pips Donuts, Portland? Oh yes, David. Yes, it's delicious. Okay, first of all, yes, no.
Yes.
Yes. Yes. Tell me why.
Because even though the dice have 6 sides, you're only rolling it twice and then you're summing it up. So you're getting one.
So go ahead.
So you're getting one answer.
How many potential answers could you get?
Tons.
So therefore, it's not binomial. In order for it to be binomial, you can have 2 outcomes. For the sum. The sum is the variable, right?
Okay.
Thank you, Jen, for proving a very important point. You have to identify every single time in your mind. I've erased it. There used to be an X here. There was an X here maybe 10 minutes ago. And you have to identify what that X is, right? If that X, as you trace down 0, 1, 2, 3, 4, if the 0 means you got 0 of that and the rest of the other. The problem with this is, give me one of the sums you can get.
13.
Well, actually, you can't do that. That's,
No, you can't.
you can get 12.
11.
Or 11. What else could you get?
7.
Or 6, or 3, or 8.
God.
Or, see, the problem is, you've got 11 different outcomes for the sums from 2 through 12, right? Right? So therefore, it's not binomial, it's 11-nomial, I guess. Please, Rachel.
If you're looking at it as a win-or-lose situation, how do you win
guys are so good at segueing for me today. Thank you. Now, let's make it a win or lose situation, because up here, it wasn't whether you win or lose, it's just the observation. That was a weird way to pronounce that. The observation, sorry, Kill. The observation of the dice, right? There's a 2, 3, 4, 5. Now it's win or lose, correct? You win if you bet on 7 or 11 and you roll 7 or 11. And you lose if you don't. It's craps. This is winning on the first roll of craps. This is wrapped up in 105. We actually analyze craps at 105 and do the averages and stuff. Now, anybody that's sitting back and saying this is trinomial, you're technically correct too. Because there are 3 outcomes, kind of. There's rolling a 7, rolling an 11, and not rolling either. But can't you collapse that down to 2 outcomes? Winning on 7 or 11, or not winning on not 7 or 11. What would the chance of winning be on that one roll? What would the chance of winning be on that one roll? You have to go back into your minds now and figure out the chance. This is the whole double dice experiment. You have to use this one to get that one.
Isn't it like 244 out of like 450?
You're thinking a little too hard. You're thinking too many dice, Dave. Only 2 dice, 36 outcomes.
Pass line bet?
Oh no. Pass line bet involves more than just the opening roll.
Yeah.
It involves also the after the opening roll. This is topic. So there's 36 outcomes of what you can get, right?
Yeah.
Throw a pair of dice. There's 36 outcomes. How many of them were 7s? Do you remember?
6.
Yes. 1 and 6, 6 and 1, 2 and 5, 5 and 2, 4 and 3, 3 and 4. How many of them are 11?
1, 2.
2 more, 5 and 6, 6 and 5. 8 out of 36 is the chance of winning that bet. 8 out of 36, chance of winning that bet. Which means you're most likely going to lose. But see, craps doesn't stop at that. And craps is a fun game. That's winning on the first roll. If you're up to a craps table and you roll a 7 or 11, you win 1 or 2 to 1 payout, and you go home. The problem is, if you don't roll 7 or 11, a whole bunch of rad crap happens. No pun intended. If you roll snake eyes, 3 or 12, you're out, you lose your ante. If you roll a 4, 5, 6, 8, 9, or 10, then it gets crazy. Because then you have to roll that number again before rolling 7. And when you add all that crap together, no pun intended again, the chance of you winning at craps is about, from memory, it's 49.2%, which is that close to 50-50. Which is, I think, why it's such an awesome game to play in Vegas, because you keep your money the absolute longest you possibly can on any game of chance. Any other game, statistically, you're going to lose it faster, because Vegas is taking it more slowly at craps than any other game. Even roulette. Even on roulette, if you're betting on red or black, it's still a little bit faster at roulette than it is at craps. Not to mention the fact that you're playing around a huge tip and looking, no! It's a fun game. It's a brilliant game, and mathematically, it's completely insane. Watching the rules, now this is just a pass line bet. There are other ways to bet too, with bigger payouts and bigger losses, obviously. But a pass line bet, man, is a really fun way to make a bunch of money last as long as it possibly can in a Vegas casino. Yeah, Dave.
I mean, for a binomial, then you pretty much said that you can just like try and see if you can reduce it to a yes or no question. Do I get a mail check? Yes or no? Do I get a 7-11? Yes or no?
Yes.
Some of the pips.
Yes. If you can make it chickens, it's binomial. Seriously. Right. If you can make it chickens. So what this is Max walked into the store and bought a bird. Did he get a girl or did he get a boy? Right? Watch this. Watch this. Can you guys see that? Hang on. That's why they put locks on the table legs, so that doesn't happen. That's all right, we'll get it later. Now you can't leave. It's like a Bronx Tale. Now you can't leave. Shit, that segment was so good, and that ruined it. I was going to take it up to the door. I just wanted you to see this. I couldn't think you guys over there could see the bottom line. Is that binomial? No. So think about it this way. I'm gonna read, just leave it on the ground, Dave. We'll deal with it. This is Max going into the store and buying a bird. This is Max going into the store
5 times.
and buying 5 birds, or going into the store 5 times. Yes, both. Either is totally fine. This is still binomial because he either wins or loses on each trial, but he keeps trying. You see, it's just like buying more birds. It's just like buying more birds. Fair? Could you put this one in your dist-fill program? I think we should, personally. I think we should put this in dist-fill. This is an interesting one. None of this is not, you can put this in dist-fill too, but it's boring. We already figured out what it's going to look like. It's 0 and 1. It's like, yeah, done. But this is more fun. Because this is, ostensibly, you're going to be interested in how many times you're going to win. on a 7 or 11 bet, right? Ostensibly. That's what I think, right? So let's mute this, fire this up. This is great for you guys that just got your program, too. You can take it for a test drive. I'd go over there to turn the light off, but I'm kind of afraid to walk in that mess I just made. Maybe Dave, you can reach up and can you reach the lights? Thank you, friend. Perfect. Thank you. Apologies. So I was a Boy Scout, and we always just set tables every Sunday for meetings, and they were big tables like that, and they had those little locks that slide down to hold the legs in place. We always got reamed because we push them across the floor just like that, and if the lock isn't down, they do that, and sometimes we'd ride them like surfboards. And that's how Matt got hurt, and that's how we got in trouble, and then we started realizing if you just lock the legs, that doesn't happen, and then you don't get hurt, you don't get in trouble. So I thought of Matt when that happened. Anyway, here we go. Program. Dist fill. Okay, smallest X, you're not going to win at all. Largest X, you're going to win every single time you play. Possible. Definitely possible, yes? Definitely possible. Okay, it's binomial. Now the probability that you have to enter is what's the chance of winning every single time he plays. Remember, reducing it to chickens, which I love that idea actually. Every time Max goes in to grab a bird, it was 90%, right? Every time he goes in to play this game, what's the chance of winning? We just figured it out. It's 836. Remember that? We just figured it out before? Every time you throw a pair of dice, there's an 836 chance you're going to get a 7 or 11. So you put that in. 836. They can handle fractions.
Would you put in for the largest? Yeah.
5, because he's playing 5 times.
Okay, 5.
Right? This is like going and buying 5 birds and keeping your fingers crossed for 5 girls. Is that fair? You guys buy that? 0 to 5? So you have to know 2 things. There are 2 things you have to know going into this experiment. The first thing you have to know is how many times you're playing. That's the first string, 0 to 5. So it goes 0 to whatever that value is. The next thing you have to know is this. What's the chance of winning on each time that you play? And it can't change. That's why you have to assume they're independent. It can't vary from trial to trial. Dave, go.
You don't need to put that in as a percentage?
No, I wrote the program to accept either a decimal or a fraction. Actually, don't put it in as a percentage, you'll get an error.
Well, wait, like 0.2.
Oh, no, you don't have to. You don't have to. I wrote it so, yeah, because it is 0.22, isn't it? It's 4, 8, it's 2 ninths, which is 0.2222 repeating. You can put it in fractions. All right, here we go. It's done. Here's the graph of it. So interestingly enough, around that. Breaking tables are right on screens. 0 wins is not the most likely. 1 win is. But this should make sense, I think, based on what Dave just said. He was very kind. And he gave us 836 as a decimal, didn't he? He said it's 0.22, which is really close to 0.2, which is really close to 1 in 5, which means, on average, you should win 1 out of 5 times if you're betting on 7 or 11. So it should be the most common outcome, right? Hopefully that makes sense. 0.22, 836, 1/5. Fair enough? Is that cool? There's your distribution if you want to see it. Now, that's not to say there's not a pretty damn good chance of losing all 5 times, 28%, 28.5%. But there's a pretty damn good chance, 41%, that you're going to win 1 out of 5. Still a pretty good chance of winning 2 out of 5. We're starting now to get into the don't bet on this to make money game bit of it, because now these are starting to fall. 6.6%, this, yeah, look at that. I mean, you're not going to win on all 5 of them, assuming the dice aren't rigged. But then we can't use the 836 anymore. This goes back to the chickens. If we get an unusual outcome like Gail's flock, do we question the sexing or do we question the outlier-ishness? And the answer is we'll never know what the true answer is, right? We'll never know. We have to weight those probabilities. That's what 244 does all the time. Good? Fair? Please, Linda.
So the 40% means you have it's a 40% chance of winning 1 time
And losing 4 times. Because you have to play 5 times. That is the key here. You have to play this 5 times. This means there's a 41% chance. So if you were to do this in sets of 5 games, so go in with $5, play 5 times, then go in again with $5 and play 5 times, then go in again with $5 and play 5 times. In 41% of those instances of 5 times each, you're going to win 1 and lose 5. Is that fair? Good. Very good question. Other questions? These are fantastic. Decent? Decent. Maybe. Okay, we're getting there. Let's turn this off. Let's keep this going up here. back down. Put the table on the ground. David, go ahead, please.
I kind of want to see the distribution for the pass line bet, because a lot of people will just go and play craps and just do the pass line bet over and over and over again.
I know. It's fairly straightforward, actually. You win with 49.2% probability, and you lose with the remainder.
I was saying, like, when you keep repeating it, like, how...
Do the quiz for this week. Do the quiz for this week, if you would. The Gambler's Ruin quiz explains it to you. It's a way to guarantee. It's a way to guarantee to earn $1 in Vegas. I promise you. If you do the quiz for this week, one of the two quizzes, one on Sarah Palin, that doesn't help you with Vegas. But the other one, I think it's based on. Has anybody done that quiz yet? Has anybody looked at the quiz yet? The Gambler's Ruin quiz. I think it's based on craps. I'm pretty sure I set it up to be a craps-based game because it's so close to 50-50. I want to use
244 out of something.
Oh!
Specific odds that you gave.
Gotcha. I understand. Yeah. So that's you do the quiz and you'll see exactly. Yeah. I promise you, I can get you $1 in Vegas. I can guarantee you $1. Earnings, like profit, right? The key of the quiz. There's a reason called the Gambler's Rule.
How much do you have to spend though to get that?
That's kind of the quiz. What you're going to be doing is doing the quiz to
Yeah,
get the
don't understand
right.
why anybody does it.
Well, because it's entertainment.
I know, but why do you think those casinos are as big as they are?
Because they take your money.
That's right.
Why did I go to see Life of Pi 5 times in the theater? Because I wanted to. Because it's my favorite book, and I get to watch the freaking movie 5 times on a big screen. I'm out like $100 doing that, right? But for me, it was worth it. For me, it was worth it. It was worth doing that. The experience, the visceral experience of actually watching that movie on a big screen was totally worth the, $15 a pop to go in, right? So that's the thing. If you can, it's all how you view it. If you view it as entertainment, it's worth your time. It's like paying money to do anything else, except you get to go stand inside this weird room that was designed in the 1970s, and they give you free drinks sometimes, depending on what you're playing, and it's entertainment. But just realize that at the end of the day, like anything else, I mean, think about it this way. How much would they look at you strangely if you went in to go to a movie and you paid them to go watch the movie? You walked in and watched the movie, hey! And you walked back there and demanded your money back. They'd kick you out on your butt, right? Well, that's what expecting money back in Vegas is like doing. You can't expect to get money back after you've played because it's negative. The negative expectation takes the money away from you, right? But people somehow view Vegas differently. View it as a movie. You've paid to go in. You don't get that back. Is that fair? Not to be a jackass, but I mean that's how their lights are all the time. That's why the Bellagio has a fountain in the middle of the desert. Much to the consternation of Californians everywhere that can't get the water into their sinks. Yeah, David.
Plus, if you take away the amount of money that states make off of gambling, you lose a lot of funding for a lot of stuff you don't want to lose funding for.
Yeah, the funding formula dance in many states is so interesting. I mean, and that's got to be an ethical conundrum for a state, right? I mean, Oregon makes themselves feel better by using this as their logo for the lottery, which I love. I love that. And then not to be used for investment purposes in like 8-point font on a billboard. Like, I guess that makes them feel better. And then Canada puts, someone just won $986,000, will you be next? I'm like, no. But I wonder how they feel like ethically about that. Like, yeah, anyway, there's a whole other story in that one, right? There's a whole other, but Matt, that's why we leave the ethics behind is look at the mathematics. At least you understand now you're going to lose your money, right?
Right.
That's the important thing. You are going to walk out with less than you came out and you went in with over time. Please realize also this does not apply to games like blackjack or poker or anything like that because those are games of skill, not pure chance. Craps is pure chance, assuming the dice aren't loaded. Roulette wheels are pure chance. Chuck-a-luck is pure chance. Those are all pure chance games, assuming the dice aren't loaded. But poker is a totally different story. You can actually, depending on how good a poker player, if you can count cards, you're golden, right? If you can count cards and you have an investor, you're golden. That's how 21, that's what the movie 21 in the book Bringing Down the House taught us. If you can count cards and you got a lot of capital up front, you can make it even more by knowing how to play the game wisely. It's all based on this. It's actually even based on less than this, believe it or not. Have you read the book or seen the movie? I forget, in the movie, do they explain the math they're doing, the 8s and the 9s and the 10s? Do they explain, I mean, quickly, they explain, like, when the count was up by 8, the drunk guy would stagger over and say something like, stop sign, they'd say...
+1, -1 count each card.
Did they talk about the code they used, though?
Yeah, they could...
Vaguely. Like, for example, if the count went up to 12, which was good, that meant that the deck was really, really, really stacked, they would mention eggs. Somehow. So this is a crazy dance, and watch the movie and or read the book, but they would somehow loudly mention the word eggs, and then the big bettors that were circling around listening would come and slam down a huge bet. Because likelihood says if the count got that high, the next few deals were going to pay off big. And that's how they made so much money. They didn't bet when the counts were down, and they bet when the counts were high. But they had these code words to indicate that. So they were doing even less math than you're doing here. Even less. They were simply counting. But they had to act that they were drunk while they were doing this, and they had to look undercover. That's what made it difficult. Yeah, Dave?
And movies like Rain Man make it seem like counting cards is a really difficult thing to do, but it seriously is a very simple system where you just see the cards that are being put out and each one has a +1, -1 value.
If you can track that, if you can track the +1s and the -1s, it really is simple. Now for an ADD guy, it's impossible. Honestly, because I get too like, oh god, oh shiny, oh lights. I mean, I get too easily distracted. But yeah, you're absolutely correct.
But that's why they use like 9 decks for blackjack.
Yeah.
Not anymore, they don't. Well, do they do that? Still do that somewhere? Because Vegas stopped doing it because of the kids from MIT.
Oh, really?
They were using a 6-deck horseshoe, and they stopped because of those kids. Because when they put 6 decks together, or 9 decks or whatever, it's not a deck, a deck, a deck, a deck. There's clumping in the 9 decks, which means there are times when all the aces show up together, and all the 2s show up together. And all they got to do is wait long enough, i.e. have an investor, for those big clumps, and then bet right then. Right? Strike while the iron's hot, I believe is the phrase, right? If you hit it right then, yeah. Vegas, the conclusion of the book was this is why Vegas stopped using 6-deck horseshoes. I'm not saying that other casinos don't do that still, but Vegas stopped. Maybe they're back now. Sorry, Elizabeth, you can't come in. I set a trap for you. Come in here. Come in here. Just be careful walking around. Yeah, kick it out of the way. That's fine. Stay out of the way.
If you had a tantrum, it looks like
No, gravity won again. Gravity beat me down again. I apologize. Stupid gravity and not safe things. Anyway.